promised, in these last two examples, we're going to combine the horizontal translations with the vertical translation. So we're going to take it one step at a time. So in this first one, we need to remember what adding 3 to the x on the inside does to this graph. And it takes this vertex and it moves it 3 to the left. Remember, adding or subtracting inside with the variable, with x, is opposite of what we would think. So adding 3 means moving it to the left. In this next one, subtracting 2 would move it 2 units to the right, and so on. Okay? And then on the outside, subtracting the 2 on the outside moves it down 2 units. So in this case, we're not only moving it 3 to the left, but we're also moving it 2 down. So that will move the vertex 3 to the left, then 2 down, to the point -3, -2. Now, once again, we can find the y-intercept of this graph by plugging in 0 for x. Again, whenever you want to find the y-intercept of a graph, substitute 0 in for x. If you want to find the x-intercepts of a graph, substitute 0 in for y. So when we substitute 0 in for x, and then do the arithmetic, 0 plus 3 is 3. The absolute value of that is 3, and then 3 minus 2 is 1. So the y-intercept is 0, 1. So here is one branch of the absolute value function. It's a straight line through those 2 points. And the other side is going to mirror that. And then we have 2 x-intercepts to find. And we're going to find those by plugging 0 in for y. So we're going to set this equal to 0 equals the absolute value of x plus 3 minus 2. And to solve that absolute value equation, the first thing we do is get the absolute value piece by itself by adding the 2. So 2 is equal to the absolute value of x plus 3. So there are 2 numbers that are 2 units from 0. One of them is 2 units to the right, which is 2. The other one is 2 units to the left, which is -2. And then we get x by itself in the middle by subtracting 3 from everywhere. So -2 minus 3 is -5. 2 minus 3 is -1. And the one that would be on the left would be the smaller x value, which is -5. And the one that would be on the right is the larger x value, which is -1. So we've labeled the vertex, we've labeled the x-intercepts, and we've labeled the y-intercept. And lastly, we'll give the domain and range. So the domain, left to right, is -infinity to infinity. The range goes bottom to top. And the bottom has a y value of -2. The top goes to infinity. So there is the domain and range of that function. And now, the last example with the graphic. Subtracting the 2 inside with the x moves that vertex 2 to the right. Adding 3 moves it 3 up. So we're going to take the vertex, which is normally at the origin. We're going to move it 2 to the right, and then 3 up. So that is going to be the point 2, 3. And then we can find the y-intercept of this by substituting 0 in for x. And doing the arithmetic, 0 minus 2 is negative 2. Absolute value of that is positive 2. And then 2 plus 3 is 5. So our y-intercept is the point 0, 5. So there's one branch. The other side is going to mirror that side. This one we're not, there are no x-intercepts to find. So we don't have to do that. We do have to give the domain and range though. The domain, once again, left to right, negative infinity to infinity. And then the range, bottom, has a y-coordinate of 3. And it includes 3, so we put a bracket around that. To the top, which is infinity. So that is graphing absolute value functions with both horizontal and vertical translations. In the next video, we'll talk about writing equations for absolute value functions where we are given the graph. So we're going to work backwards.